Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so you should check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode to get a $20 credit and launch a new server in under a minute. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. Your host is Tobias Macey, and today I'm interviewing Jan Stücke and Jan Steeman about ArangoDB, a multi-model distributed database for graph, document, and key value storage. So, Jan 1, could you start by introducing yourself?
Yes, hello. My name is Jan Steeman. I'm a developer here at ArangoDB in Cologne, and I'm working on the core functionality of ArangoDB that is mainly the query language of ArangoDB, cluster functionality, and lots of the internals. And I focus on these kinds of things and also performance optimizations of these things.
And Jan 2, how about yourself?
Yeah, hi. I'm Jan Stücke. I'm the head of communications here at ArangoDB. I joined nearly 3 years ago. And I'm mostly concerned with communicating ArangoDB and creating technical documentation and training stuff and helping the community on Slack, for example.
And going back to you, Jan 1, do you remember how you first got involved in the area of data management?
Yes, so it's a while ago. I've been using SQL databases for at least 15 years, I'd say. I wrote a lot of SQL for other databases and was always involved into how to make SQL queries perform well and all this. And eventually I got into performance optimization of SQL and looked into source code of other databases and tried to hack around there. And when I got the offer to join ArangoDB, it was actually not named ArangoDB at that point of time, but it was still it was already a database company. So I took the offer and I always want to work on a database of my own. And so I accepted that offer and I'm pretty happy I did it.
And Jan 2, again, how about yourself?
So I'm coming more from the product and communication side. So my first job in the tech industry was, I think, 9 years ago. Then I designed software processes for an e-commerce platform. And then more and more developed into the direction of project management and product management. And then worked at another company called Next Level, which is an IT recruiting company. And there I was mostly responsible for voice and tone and all this communication stuff. And then, as I said, 3 years ago, I joined then ArangoDB as a communication and marketing team. And here mostly focus on all the technical communication stuff.
And I gave a high-level description of what ArangoDB is, but I'm wondering if you can give a bit more detail about the product and what was the original motivation for creating it.
Sure. So in a nutshell, ArangoDB is a distributed native multimodal database, and we support, as you already mentioned, key value, document, and graphs. So the database also supports join operations and multiple graph algorithms like shortest path or pattern matching, but also distributed graph processing with Preamble. We're open source, so under Apache 2 license, written in C++. And ArangoDB also supports ACID transactions. And at its core, it's a schemaless database. But if you want to validate a schema, you can also use our Fox framework for data-centric microservices. Fox is basically a JavaScript framework based on Google's V8 engine that you might know from your Chrome browser. And what it does, it is allows to bring data-intensive business logic closer to the data. So you can run queries directly on the server and any kind of business logic that you like. So we also have, of course, a cluster management, which is based on the Raft consensus protocol, which we integrated into our agency, which is basically the brain of our cluster. The roots of ArangoDB go back to 2012. So the project was started there, and the company was founded then in 2015, when we also received our initial funding. And in 2017 there, we were pretty happy to announce that we could close the seed round led by Target Partners, a tech investor here in Germany, and received a total funding of around 7 million. So the idea and motivation of our two founders, so Frank and Claudius, roots in their previous business. So both are pretty experienced in building databases for over 20 years now. And prior to starting the ArangoDB project, they already had a successful database development consulting company called Triagons. And they did projects for New York Stock Exchange, Deutsche Bank, you name it. But what they learned during this time is, yes, you should use the right data model for the right job, but why do I have to learn a complete new technology for doing so? Frank and Claudius then found a way to combine these three data models, and that was basically the moment that gave birth to the ArangoDB project.
And you mentioned that when it was first created, it didn't bear the current naming. So I'm wondering if you can share where the name ArangoDB came from and what was the motivation for the avocado as the mascot.
Yeah, the name. We get this question a lot. So at first, we wanted to call ourselves AvocadoDB because there are, I think, around about 1,000 varieties of avocados on this planet. And what we like is that they all look similar from the outside, but if you take a closer look, then they are quite different. And this reminded us a lot about how people see data or might perceive data. But there was another company, from my understanding, not at all a similar name, and they threatened to sue us if we keep the name. So we had a look at the 1,000 varieties of avocados and choose ArangoDB because we thought it sounded fast. And today, I think we're all pretty happy about choosing ArangoDB as our name.
And so, given the fact that it's multi-model and it's all running on the same engine, there must be a single way of representing the data at the storage layer. So I'm wondering if you can discuss how the database is constructed for being able to support all of these different views on top of the underlying storage layer.
We have storage engines in the background. So ArangoDB provides two different storage engines. Both have totally different sweet spots, and they share a common interface. And the storage engines just they handle the very low-level operations for retrieving the data, for storing the data. Like, for example, get a data by primary key, store data by a primary key, or do an index scan over a specific range, something like this. So at the storage level, it can be quite different how these storage engines implement actually the data retrieval and data storage. But on the layers above that, we have our query language and all these higher level APIs that the users interact with, and they provide different views on the same data that is stored by the storage engines. So it allows basically to get the data from the storage engines and to use the same data in document style queries or table relational style queries or in graph queries, and to bring all this together and to put the same data that is hosted by the storage engine more or less to make use of that and to bring all this data together and to analyze that or view that in different fashion more or less.
And when you're storing the data, do you need to determine at write time which interface you're going to use to view it? So do you need to say this record is being stored as a document, this record is being stored as a node in a graph, or is it something that can be dynamically modified where you maybe store it as key value and then later construct a graph between nodes and be able to query it via different semantics at read time?
Yes, and I think that's one of the strengths of ArangoDB. So when you store the data, you don't have to know upfront that you will use the data in the graph later on. So you can basically just go ahead, store your data, and later bring it together by more or less running a graph query on it. And this is as I said, is one of the advantages. You have your data that you have stored, but you can analyze it in different ways later on, and you don't have to know all the ways up front.
And with different ways of querying the information, I imagine that there are different performance characteristics. So are there ways that you can tune the storage layer or tune the way that you are writing or indexing the data to give better performance based on certain query patterns?
Yes, so all the data obviously can be indexed in different ways. So we provide several different indexes, and you can choose the right index for the work at hand. Basically, the storage engines also come with different sweet spots. So one of the storage engines keeps most of the data in main memory, so it's pretty fast if you do if your data set fits in RAM. And the other storage engine is based on ArangoDB, which allows handling much greater volumes of data. And they provide a lot of tuning parameters. There's the indexing that can be done. We have our query language comes with, I'd say it's a quite complex query optimizer that tries to optimize the queries that are run against the data. It also distributes the data appropriately in the cluster, and the individual query parts are automatically distributed across the nodes of the cluster. So there's a lot going on in the background, and if there's manual tuning required, there's a lot of configuration parameters that the users can still choose to modify.
And what are some of the benefits that a multi-model data engine provides versus something that will only support relational or document or graph or key value storage?
Yeah, one of the main benefits is that it doesn't force you into a specific direction. For example, if you migrate from a SQL-based database where you have this relational model with the tables and all the rows in the table have the same structure, you can migrate this model easily to ArangoDB, because in ArangoDB we have these collections, and the collection can just be seen as a table with all the documents in the collection having the same structure. But if then you find that you want more flexibility, then you can start by making modifications, and you can, for example, give certain documents a different structure. And you can then later on bring all the data in the tables or collections together by adding indexes, by joining them. You can also add parts of them or all of them to a graph and later use them in graph queries. So you're not forced into a specific mode or model from the beginning, but you can do this more or less as you can see fit, and you can adjust to your needs, basically.
And are there any cases where having the multi-model view of the data becomes problematic or confusing for users?
I think that's a very good point. So internally, I would not say that we face any other challenges that other distributed databases face. Supporting multiple feature sets for the different models is, of course, a bit more work compared to a single model database, for example. So a bit more work on the query engine, maintaining AQL, build new functions there, and all that stuff. But I don't think this is anything inherently problematic to multi-model itself. For users, that's a very good point. So I think it's cool to have a database that allows you to do a lot of things. But what our users often face is that now that they have the simplicity to choose, I can use a join, or I can use a graph traversal, or whatever access pattern they want to use. The question is, which one should I use for my application or for part of my application? And we try to help our community a lot with our community support on Stack Overflow and on Slack. And also provide as many training content as we can, so we make it clear when to use which access pattern. So I think a general rule of thumb that is good for initial guidance is, if you know the depth of your search before you search, then the join tends to be more efficient compared to graph traversal. But a graph traversal is perfect if you don't know the depth of your search, or if you're searching in a range or a varying depth. So as graph is not a super new concept, but gained a lot of popularity over the past years, but it's still young. I think getting comfortable and used to working with graphs is currently our task. So educating our users and helping them to get used to using the different access patterns.
Are there different approaches that are necessary when doing your data modeling versus a relational engine?
So basically, you can more or less model the data the same as in a relational engine in the very beginning. And this also allows, as I said, migrating from a relational database to ArangoDB quite easily, because you can have your tables as collections and then use joins to bring the data from these tables together, provided that you've set all the indexes as you would do in a relational database and so on. So this would work all the same. But then you can really, once you've done that, you can then think of making any extensions or adjustments that wouldn't be possible with the relation engine, like really making use of the document structure or of the document model, that you really have the flexibility of having different attributes per document. So you can have like variable attributes, if you like. You can also utilize the power of graph traversals. So for example, you can put relationships between different things and model them, and treat your data more or less as a graph and do traversals, like starting at a specific document and find all the things that it's connected to. One of the basic examples would be like a social network where you have a person and you want to find the connections of these persons, not only the direct ones, but also the indirect ones, which is one example that's always used. But there's other examples where you can make really use of the graph approach. And for example, modeling a network or components in a network is a perfect example of modeling data as a graph. And with the ArangoDB, you can just do this. So you have all your data in the individual collections. And later on, as you see fit, you can bring them together by defining a graph that consists of these collections and the relationships between them, and run queries on them. And one thing, so users coming from a relational engine or from a relational database, they will be accustomed to using SQL. ArangoDB doesn't have SQL, so there is something else that they would need to use. We have a query language that basically allows to do all the data retrieval and modification that SQL does, but it's not SQL, it's AQL. ArangoDB query language. It's similar in the concepts to SQL, but it has a slightly different syntax. So this is basically the main thing that users need to keep in mind should they be coming from a relational engine.
And there are some other multi-model databases in the market, most notably ArangoDB, and in some capacity you could even think of Postgres as a multi-model database. So how do you view the position of Arango as compared to these other databases that are available?
Well, in terms of ArangoDB, the basic difference between the both technologies is that ArangoDB is C++ based and ArangoDB is written entirely in Java. ArangoDB offers an SQL-ish dialect to retrieve data, and ArangoDB, as Jan already said, uses AQL to combine all the supported data models. As far as I know, ArangoDB, they don't have something similar to the Fox framework. What I personally like about ArangoDB is the ArangoDB Studio, which is their web UI, and you have a lot of nice visualization options, for example, for graphs and stuff. And yeah, we have to catch up. At the moment, we have functionality-wise a good web UI. You can also visualize graphs and have some layout options. But I think from the beauty side of things, we can improve there. For more details, I would not feel comfortable to comment more on ArangoDB because I'm just not an expert, but I think everyone can Google about some feedback or experiences or the specs about technologies. But I think in general, we have to see what happens now to ArangoDB after they got bought by Kaleidos Cloud and Kaleidos Cloud got bought by SAP. So I just don't know what will happen to the project. In terms of Postgres, Postgres is a great database, period. So they are now there for, I think, over 20 years. They built in a lot of great functionality and a lot of, I would say, what I can read on the internet, also fast and stable. I can't at the moment say anything about their abilities to do graph algorithms like pattern matching or shortest path. We try to include Postgres and those queries into our open source performance benchmark just to get a feeling for ourselves, but we just didn't manage to get this done. We already reached out to our community, to people who have experience with Postgres, but as far as we can tell, no one could manage to do those graphy queries efficiently in Postgres. So I think this is a difference. And at least to our performance benchmark, everyone knows vendor performance benchmarks might not be always fair or could be biased. We open sourced it completely, so everyone can test it for themselves. And I think with a tabular model and aggregations, Postgres is without competition. They are super efficient and very good. But when you want to use the schemaless JSON-B option, then it is not working that efficiently as far as we could measure in our testing. But nonetheless, Postgres is a great database, and we have a lot of respect for the team and the community behind it.
And one of the core features of Arango is the ability to scale across multiple nodes. So I'm curious how that functions in terms of the ways that you're able to do things like transactional queries across multiple instances and some of the difficulties that you've been facing as far as offering those scaling options.
Yeah, let me first start with, so ArangoDB can be run in different modes. So the most basic mode is the single server variant that you obviously cannot scale, but ArangoDB can be run as a single server instance too. You can add replication to that just to achieve high availability and to have a failover node in case your master node goes down. We also provide a mode to handle all this failover things automatically. But then there's also this cluster mode, which is designed from the ground up to be run on multiple nodes. And it's more or less a shared nothing approach. So all your data is stored on just specific servers. Obviously, there's also some sort of replication going on. So in case a node goes down, you still have a backup of it. So it's resilient. And there are definitely challenges in developing a cluster database. Not only that you have to store all the data at different positions in the cluster, so it's highly available and you have a backup. But also if you have a complex query language like we do, and we do joins and all this, this is really quite a complex matter internally, and especially also when it comes to transactions and consistency. So this is really a complex matter, and it would go beyond the scope of this podcast, I think, if we discuss all the details, because really, really many things to consider there. And we're trying hard to optimize this as much as possible and to make queries as efficient as possible in a distributed database, which is probably a never-ending endeavor. And currently we are putting a lot of work into our query optimizer so it can dispatch things to just individual shards that will actually host the data, and to move data as close as or the operations as close as possible to the actual data in the cluster, to parallelize all of that. And this is really some big challenge, but it's actually nice. So it's a lot of fun from a developer perspective.
Yeah. So maybe just to add and to be open and clear about it. So we support full asset transactions in a single instance and also in the automatic failover setup. In a cluster, we support a single document and single collection transactions. So we have no distributed transactions at the moment, but we're at least thinking about it if we want to support this as well.
And in terms of the network architecture that you're able to support for the highly available mode or for the clustered mode, what are those limitations, such as being able to distribute across multiple data centers, or in terms of the volumes of data that you can manage in the clustered option?
Yeah, so the cluster version of ArangoDB is basically, it's designed for the use case that all nodes of the cluster are relatively close together. That means in the same rack or at least in the same data center. So it's not really been designed for planet scale installations, like where you have all your nodes in different data centers across the entire world, because that would then require wide area replication of the data. So it's not designed for that. So our sweet spot for the cluster is basically when all your nodes are close together. And if you still want to have multi-data center resiliency, like if one data center goes down and all your nodes go down there, and you still want to have a backup, then we provide a solution for that, but it's only in our enterprise version. It's called data center to data center. It's some sort of replication that replicates the data from one entire cluster to another, which can also be geographically far apart. So that is then supported, but basically if you have just one cluster installation, it's designed to run on nodes that are close together. In terms of data volume, obviously the cluster version is designed for scaling out. So you can add more nodes, and these nodes can handle additional incoming requests from client applications. And these nodes are also then used to store more data. So we have two types of nodes in our clusters. We have the coordinators, which are more or less doing request processing and request dispatching. So adding more of them will allow to have more CPU power for running queries. And then we have the actual data nodes, which are responsible for storing the data and retrieving the data. And if your data volume grows, you can add more of them. And basically these are the things that you have to keep in mind and when you want to scale out. But it's not like Google Spanner that you would put a million of nodes together and have them work as a single cluster.
Yeah, I think maybe one important thing to add is that we don't see the actual storage of the data the problem, but rather accessing data efficiently when they are stored on different machines. So what we allow also in the cluster is to scale with all three data models, and also with and doing complex queries at scale. So when you think about a graph traversal and you think about a graph, so for example, Tobias knows Jan and Jan knows the other Jan, and you have to shard this three-node path to different machines, and you then want to query exactly this path. Then you have network latency for the query. And the same is true. For joins at some point. And if you now want to provide an efficient query execution, then you have to find a solution or you have to have access to the data locality and also store the data so that the query can be processed locally without the network latency, or at least reduce the network latency to a minimum. And this is currently a challenge that we're working on. We have for joins and for graph traversals also a solution for that. But of course, it is rather new development and there's still some room for improvement. But I think taking a look at the current market, we're already pretty far.
And one of the other features that is fairly unique to ArangoDB is, as you mentioned, the Fox framework for being able to embed microservices into the database. So I'm curious what benefits that provides over the traditional three-tier architecture of having a web server in front of the database for being able to run those transactions.
So in the classical three-tier setup, you will have your web server execute a lot of queries against the database. So if all the business logic is executed on the web server, it will typically run a lot of queries. So for retrieving some data, for manipulating some data in the database, and that normally means you will have a lot of round trips between the web server and the database server, which can actually sum up if your business logic is complex. And with the Fox framework, you can more or less avoid that, because you can have your web server just issue a single request to ArangoDB, which is then handled by a custom Fox REST web service, more or less, that is running in ArangoDB. And that can do anything that the application developer wants it to do. It can, for example, query all the data that is necessary for serving this particular request and do all the data manipulations in one go, and then can come back with one aggregated response. So basically, it will save a lot of network round trips. So it's a performance optimization, basically. And the good thing is that application developers can tailor more or less these custom REST APIs as they see fit. So it's really up to you as an application developer what your Fox REST APIs can do and will do. So you can put in all the things that you require, like validation of incoming data. You can do all the things like access control and all this. This can all be done there. But after that, you are close to the data already, so you can run all your queries against the data with relatively high performance, and then return with an aggregated result to the caller. So I think it's superior to that. In terms of performance, it will be superior to the classical three-tier approach. But obviously it mangles a lot of layers together into one, which several people don't like. And I'm not saying this is good or bad, but I mean that's the trade-offs that you have to do. You get a performance benefit, but then you have more code running in the database.
And how does it compare to things like stored transactions or functions in something like Postgres?
Yeah, basically it can be viewed as the same thing. So you basically whether you use prepare a transaction or prepare a function and then simply execute it later on. Fox is actually the same. You deploy some custom REST API to the web server and then you just call it and it gets executed. But basically what Fox basically can do is a lot more than just executing queries. You have full access to JavaScript. So actually your Fox APIs are written in JavaScript. So you have the power of a scripting language actually to implement whatever you need. It's not limited to running just queries.
And do you have any mechanisms in place to help prevent against security vulnerabilities or data breaches in the code that you're writing within the Fox framework?
So basically, from our point of view, the Fox code that's written is just arbitrary script code, more or less. So it's up to the application developer to not leak any data that is sensible and things like that. But we have something in the framework that makes it relatively easy to do, for example, validation of incoming requests. So all the routes that you write for a Fox REST API, they have a schema for the incoming data, and any data that is not conforming to any incoming requests that are not conforming to the schema are automatically rejected. So you as an application developer can make sure easily that you only get valid requests that do not contain any data that you don't want to see there. And obviously then you can implement all the things like access control and parameter validation on top that you want. There's also like access control built into ArangoDB for all these for the collection and the databases. So there is actually something that can be done. But apart from that, it is script code that the application developer is writing. So there is still the potential of leaking some data if something is not right. But we also recommend to not expose a Fox web service to the internet, but still to have a web server in front of that. So you still have the classical mechanisms of the web server shielding more or less the database, and you can still put firewalls between that. So we still recommend to do this and use Fox more or less as a performance optimization. So a web server only has to more or less make a single request against the database and not a lot of.
And are there any particularly interesting or novel uses of the Fox framework that you've seen?
I think, first of all, it surprises me personally how many people are actually using Fox. I always thought that it is 10-20% make use of it. But I think it's a safe bet to say that more than half of our community is doing at least something with Fox. I think the most interesting use of Fox that I saw was quite huge hospital. What they did was do the access control permissioning completely in Fox. So they store personal and medical data in their database and, for example, give the doctor access to all the medical information, of course, the name. And the accountant of the hospital then has only access to the name and for example, the account or address data. So what you can do with Fox is do this permissioning down to the field level. This was one surprising thing. I didn't think about that, but it was pretty cool. I mean, when I asked the developer, he said, "Yeah, well, I can learn a complete identity and access management tool, which has basically the same complexity as a programming language. So I stay with my knowledge about JavaScript and write those services in Fox." Another one that surprised me was I thought that Fox was more for people who have a really sound technical background. But the guys at Thomson Reuters, and they also wrote a use case about it, so I can talk openly about it, also have business analysts who are writing quite complex queries and put them into a Fox service, and thereby take a lot of work from the developer side. So those are the two things that surprised me, or that I thought, okay, that's new.
And what have been some of the most challenging technical and or business aspects of building and growing ArangoDB as a technology and as a business?
That is a good question. I would say that it is true for every database that the technology has to provide substantial value to the user. Otherwise, you won't get anywhere as a project. Transporting the value of ArangoDB to developers and also companies, while there are currently around about 400 other databases out there where developers can choose from, is of course not easy, but I think that the ease of getting started with ArangoDB and the power of our query language, and most importantly, the long-term benefits of the multimodal flexibility gives us an edge there. But of course, other teams and other vendors are not sleeping. So this is definitely a challenge on the business side. I think native multimodal is still new to many people, despite being around for over 5 years now. I think we are already past the does this really work question, and more people are testing it for their use cases. But nonetheless, multimodal poses a new question that we discussed slightly before. So if you have now the possibility to choose between different data models and their related access patterns, you really have to decide which is the best for your application or for your use case. And this poses, of course, some new questions. On the technical side, I would say that our current challenge is to provide at least a similar experience people make on when using ArangoDB on a single instance, also in the cluster, which of course leads to challenges in executing complex queries efficiently. So with smart graphs and satellite collections, we, as I said, already have, I think, pretty good answers, but I think there's still some sleepless nights in front of us. Another current challenge is that we're working on integrating Arango Search into ArangoDB. Arango Search will be part of ArangoDB 3.4, which will be our next release. And ArangoDB and Arango Search. So Arango Search, maybe to describe Arango Search just real quick, Arango Search is a full-text search and ranking engine. It is a project based on iResearch, which was developed by a team at Dell EMC, who used already ArangoDB 3 years ago and based iResearch on it. It was open source by Dell EMC, and last year we were very happy that the team who actually developed iResearch then joined ArangoDB and is now working on integrating it into the latest version and the upcoming version, of course. And the challenge here is that ArangoDB and Arango Search are both pretty complex code bases. Marrying them is the first step, and I think we already did a good job there. But now we also want to, of course, provide Arango Search in cluster usage. And this is, of course, a whole nother story, but I think we're on a good path there. But as I said, it's not that easy. Another thing that we're working on is that we want to provide managed services. So more and more vendors offer managed services for their database, and we think it's the right way to go and something useful for people and something that people want. We're already planning in this direction, but it is also nothing trivial. So if you want to do it the right way, it takes also some time. But I think over the next couple of months, we will also provide something in this direction.
Are there any other aspects of the project or the business that we didn't discuss yet that you think we should?
A few things, I would say. So as I said, Arango Search will be in the next release of ArangoDB versions 3.4. What we will also integrate there is extended geo functionalities. We integrated a new geo index, which is the Google S2 index, because we also want to support more geo primitives. So at the moment, we support points and also ranges based on our geo cursor. But of course, this is for many use cases not enough. So what people want is polygons and multi-polygons, intersections, multi-line strings and all that stuff. So this will also be part of 3.4. Some other useful things is, for example, schema validation, JSON schema validation on C++ level, incremental backups, and other useful things that we get asked for a lot of times. But of course, we're still a young and small team, and it takes a bit of time, but we're also working on that. Another bigger thing, because it's not that easy to do and to do it right, is a relaunch of our web UI. So as I mentioned before, we want to provide a better user experience and an easier use of our web UI, and also the graph visualization options and providing better teamwork with graphs. So this thing, but I think the biggest thing or the foreseeable future will be managed services.
So for anybody who wants to follow the work that you're up to or get in contact, I'll have you add your preferred contact information to the show notes. And as a final question, from your perspective, what do you see as being the biggest gap in the tooling or technology that's available for data management today?
Well, I think if you take a look at the database market over the last, let's say, 20 years, then you had generally two directions. So over the 90s, you had databases focused a lot towards storage efficiency, but not on scaling out. And the other direction then started around the 2000s, was focused a lot on hyperscale while sacrificing a lot of functionality. I personally think that there's a stack of technologies missing that can easily scale to a 2-digit machine cluster, for example, and work, of course, in a distributed setting, but also provide a rich and deep feature set. So I think this technology has, of course, to integrate smoothly many development processes. And I think this is a huge gap, but also a huge demand for such kind of a technology.
Well, I appreciate the both of you taking the time out of your day to join me and discuss the work that you're doing with ArangoDB. It's definitely an interesting project and one that I've been following for a while now, so I appreciate that, and I hope you enjoy the rest of your day.
Perfect. Thanks a lot for having us.
Yeah, thanks a lot, and enjoy your day too.
Take care.